Hey everyone, in this video we're going to look at another way of doing the gradient. So we know that the derivative gives us a gradient function and we can substitute in a value of x to get a gradient at a point. We can also do rise over run to get the gradient, but we're also going to use the tan ratio. So that's why I've got the trig functions here. All right, so I've just copied that into a Word document because it was way too squishy on that PowerPoint. So for your gradient, there are three ways you can do it. All right, so we can do, first way is your rise over run, which you learnt about. You can also do the derivative. And the one that we're going to cover today is tan theta. Now, you're probably thinking, well, how does tan come into it? Well, let me just draw a quick diagram for you. So if I was to have my axes, and I'll quickly draw a graph. So I went like that. And we wanted to know the gradient. All right, so we would usually just do a rise over run. Now, we can also think of this as a right angle triangle. So if I've got here theta, then that would mean that my rise would be my opposite side and my run would be my adjacent side. So I can actually say, well, my gradient, which is rise over run, is also the same as saying, well, that's the same as my opposite side over my adjacent side. And understanding, SOHCAHTOA, your trig ratios, opposite over adjacent is tan theta. So that's what we're going to be learning about in this video. And that's what I've got written in green. All right, so I've got the exact values there because we're going to use them for question 9. So when we do circular functions, you're going to have to remember these exact values off by heart. But for this question, we'll just use that table. All right, so let's have a quick look at question 9a. So I'm not going to do every single one, I'll just get you started. So find the value of x such that the tangent line to the curve curve f of x equals x squared minus x at some point makes an angle of 45 degrees in the positive direction of the x-axis. All right, so it's important that we note that it's the positive direction because if I just go back up to my diagram up here, this is the positive direction of x. So if we wanted the positive direction, it would be that angle there. If we wanted the negative, it would be that angle there, all right, on the other side. All right, so let's find, all right, so we're solving for x. So we're going to find f of x, and that is also equal to tan theta. I was about to write x, tan theta. All right, there are two ways of finding the gradient, just like we knew that it was also equal to rise over run. But we don't need that for here, but you can use the fact that they're all equal to each other to find the coordinate. All right, so I'm just going to get rid of that last one because we don't need to use that for this question, and my son's just come home and he's going to be noisy. All right, so the derivative is 2x minus 1. All right, so I'm just finding the derivative of this function. And it's asked us for tan 45. So I'm just going to do tan 45, and this is where your exact values come in. So looking at my table, let me just scroll up. All right, I've got tan going down to 45 degrees. It's equal to 1. And then we're just going to solve for x. So taking that 1 over, taking that 1 over, yep, so that gives us 1 plus 1 is 2. And then x is equal to 1. So if we're just finding the x value, it's 1, but if we had to find the corresponding y value, we just do f of 1, and we're just substituting it into our original function. So 1 squared is 1, minus 1 is 0. So there's your point, 1, 0. All right, you can go on and do exactly the same thing for the others. So the only thing that changes is this angle here. So for the second one, we got 135. All right, so that's going to be equal to -1. So you just go through and solve that. All right, there was another question on the PowerPoint. Whoops, wrong one. All right, so for this question, we're kind of just doing a bit of the opposite. So let's just have a read through. So we're finding the angle this time as opposed to the point. So for each of the following, find the angle that the tangent line to the curve makes with the positive direction of the x-axis at a given point. All right, so let's just get my pen ready. I can do this on here, and I might show you also on Desmos. So we've got our original function, y equals x squared plus 3x. Now, if I'm finding the tangent, my tangent is in the form y equals mx plus c. So I can get my gradient from the gradient function. All right, so dy dx is equal to 2x plus 3. And we're doing the tangent at the point x equals 1, so I just need to substitute in x equals 1. So dy dx is going to equal 5. So that's the gradient of the tangent line. If I wanted to go on to find the rest of the information, so basically your y-intercept, we're going to sub in the point 1, 4, because the tangent line goes through that point, and m equals 5. So I would have 4 equals 5 times 1 plus c, and just finding c. So that's going to be 4 minus 5, so it's going to be -1. So the equation of the tangent line is equal to y equals 5x minus 1. Now you can do this a lot quicker on your calculator. So if you want to check, we could just go interactive. And where is, maybe not yet, calculation line and then tan line. Our expression, so we don't need the y equals part, just the x squared plus 3x. And just at the point, the x coordinate, 1. All right, so there we go, 5x minus 1. So you can get it that way as well. We didn't have to calculate the tangent line for this one, but I just thought I would show you what it's actually asking. If you're thinking from the previous question, what was the point of all that? All right, I'll show you this time with a graph. So let's go on to Desmos. All right, so we can put in our original function. So x squared plus 3x. Oh gosh, where am I? Y equals x squared plus 3x, and then I'll just put the tangent line in as well to x. No, that's not the tangent line, that was the derivative, you silly Billy. What was it? 5x minus 1 from memory. All right, and it told us it went through the point 1, 4. So we can see that here, that point of intersection. It might be a bit hard to see there because the tangent line goes very, very close to that point. All right, so there it is. Where are we? 1, 4. All right, I want to put the point on there. Actually, what we can do, I think this will work. 1, 4. There we go. All right, and we'll put a label on it. All right, so there's the point. The tangent line is going through that point. So the gradient, so remember the instantaneous rate of change? The analogy I used was the speed camera. So it's at a point, so the gradient at this point is 5. So the gradient of the tangent line is also 5. What we're finding in this question, let me just screenshot this, make it a bit easier. Copy, and I'll put it into this Word doc that I was using before. I can. No. Oh my gosh, guys. This is why I have so many tabs open. I never really close things. And all right, so there's our tangent line. We want this angle here. So we can think about, well, this point here, we're going rise. Let me just get rid of that. Remember, we're going rise over run. So this point here looks like it's -1. So we've gone up 5 and across 1. So there's our gradient as well, rise over run, 5 over 1. So we're finding this angle here. All right, that's theta. And that angle there is the same as this angle. All right, if you're wondering why I've drawn it there, I just wanted to show you that rise over run. But we usually just do it from the axis. All right, so you can see there's your right angle triangle. We're finding that value there, theta. All right, let me go back to the question. Where was I? All right, so that just means tan of some angle is equal to 5. So your angle is equal to inverse tan of 5. And just make sure in methods, this is pretty much the only time you need to have your calculator in degree mode, because we're used to having it in radian mode for circular functions. So for this one, we need it in degree mode. So we just go into our trig, inverse tan of 5, all right, and there's our angle, 78.69 degrees. And when we looked at the diagram on Desmos, all right, we can see it is quite steep. All right, so we've got a right angle there, so it's quite steep. We would expect it to be around 78.69 degrees. All right, so you can go on and do the other questions exactly the same way. I strongly encourage you to have a look at the work solutions as you're doing these questions, because they will just set it out for you, just in case there's any confusion. So you can access your work solutions from your textbook. All right, so your online textbook, and then just go work solutions. I might also just put them on our OneNote, because we are doing some new stuff that you might be thinking, oh, this looks a bit tricky. So I'll put them on our OneNote as well. All right, bye guys.